Hello guys, welcome to our first lesson of the year, pre-AP, pre-calculus. Just kind of wanted to give you a heads up. So we're going to start out with chapter 1, but I have decided to skip section 1 and 2 of our textbook because if you're taking pre-calculus at this point, you should already know what a function is. So we're going to go ahead and skip to section 3 of the textbook. By the way, I kind of wanted to give you a heads up as well. Here at the beginning of the year, a lot of the material that we're going to cover in this class is a review of Algebra 2. So even if you feel a little shaky about your Algebra 2 knowledge, hopefully by recovering some of those material that you learned last year at a much faster pace, you'll feel a little bit more comfortable. But anyways, let's go ahead and get started. We're going to start out with section 3 of our textbook, which is titled Graph of Functions. So the very first thing we're going to talk about on this section is what a parent function is. So remember, a parent function, here's a definition, is the simplest function of a family of functions that preserves the shape of the entire family. In other words, you've run into this before. So like a linear function, the parent function is y equals x, but you can do all types of transformations to that, right? You can stretch it, you can compress it, you can shift it up, down, left, right. So that's what it means by a parent function. A parent function is the simplest of them all without any transformations whatsoever. Okay? So what I would like for you to do at this point is to explore and investigate or try to see if you can recall what these parent functions look like that you learned back in Algebra 2. So in order to do so, what I'm going to ask you to do is I'm going to ask you to graph, and I want you to find the domain and the range of this 11 parent functions here that I'm going to list out for you. So we've got this 11 here, the linear, the constant, etc., etc. In case if you forgot what those are, I gave you what the actual function looks like. So you can either use your calculator to explore, you can go online and try to see if you can figure it out, or honestly, if you think you can remember what this looked like, then go ahead and give it a shot. I want to bring your attention to a couple of the functions. For the constant y equals c, you're going to have to come up with your own example where c is just a constant, so you can use like y equals 2 if you like. Same thing for the exponential and the logarithmic. In order for you to have an exponential function, you need a base, but that base has to be greater than 1, so you can use 2, 3, 4, doesn't matter. Same thing with the logarithmic function. That base has to be greater than 1. And lastly, this is one that typically students don't know or never been introduced to, or really, quite honestly, can't remember it, and it's called the greatest integer function. In order for you to be successful at it, I would recommend that you actually look up the definition of what the greatest integer function is before you give it a shot. Okay, so go ahead and pause the video, graph all of this, come up with the domain, the range, and the graph. Okay, I'm assuming you gave it a go, and by this point you have the graph of all 11 along with their domain and range. So let's go ahead and go over them. So here I'm going to use this document I found online to kind of go over it. So here we have the y equals x, which is a linear function. Here's what the graph looks like. Its domain and its range would be all real numbers. One thing I do want you to write down on your notes right now is that this function is considered to be odd. I will cover what that means in a future video, but I would like for you to write that down on your notes, please. Here's your absolute value function. Here's the graph. The domain would be all real numbers, negative infinity to positive infinity. The range would be 0 to infinity with a 0 being inclusive. Here's our quadratic. Oh, sorry, and I forgot this is an even function. Quadratic is also an even function. Here's what it looks like. The domain is all real numbers, and the range will be 0 to infinity, including the 0. Y equals root x would be your radical function, and it is considered to be neither. Again, I'll explain to you what that means. Both the domain and the range will be 0 to infinity, including the 0. Here's your cubic. It is an odd function. Domain and range will be all real numbers. Cube root. Domain and range will be all real numbers, and it's also an odd. Your exponential, this specific example, they chose to use 2 as the base. So here's what it looks like. The domain would be all real numbers, and the range would be 0 to infinity. I want to bring your attention to the fact that 0 is not included because there is an asymptote located at y equals 0. With the logarithmic, they decided to use a base of 2 as well. The domain and the range are listed here, and the reason for the domain being 0 to infinity is because there is an asymptote at x equals 0, and you cannot touch that value. Here's your rational function. It is considered to be odd. The domain in the range will be negative infinity to 0 and 0 to infinity. The reason for that being is that there is an asymptote at y equals 0 and at x equals 0. And I think I forgot to mention that both of these are neither, and we'll talk about that later on. I did not ask you to grab this one, so you don't have to worry about that one. I'll come back to this here in just a second, but here's the constant. The person that came up with this decided to use y equals 2, so here's what the graph looks like. Its domain would be negative infinity to positive infinity, and I want you to pay attention to the way that the range is written. First of all, this brackets here, there are a symbol that means the set. So when you see this brackets, it says the set, and it basically says the set of y values such that y is equal to c, which in this case would be 2. So your range would be the set of y values such that y equals to 2. Okay? Now, the greatest integer function. So let's talk about the greatest integer function. So let me go ahead and give you a definition for this. So I'll go ahead. I wanted to look it up with you. So let's go ahead and look that up. Greatest integer function definition. And let's see what Google says to us. Here we go. Let's see. Maybe this first. Okay. So first of all, it says the greatest integer function is a piecewise function. So as you can see, it's made up of a bunch of pieces. And here's really the definition where I wanted you to look up. It's basically a rule, and it is the greatest integer that is less than or equal to the number. Okay, so let's go back to the graph and see what that means. Okay, so here's the symbol for it. So when you're graphing, you typically plug in numbers, right? And then you shoot out a number, right? So according to the definition, if you plug in 1, what is the greatest integer that is less than or equal to 1? Well, the answer should be 1. And if you plug in 2, the greatest integer that is less than or equal to 2 should be 2. If you plug in 3, it would be 3, and so on. So as you can see, you can plot all those points, but as you start plotting those points, that you would get the 1, 2, 3, 4, 5, 6, and that would just be a line, a linear. Well, it obviously cannot be the same as a linear, right? There's a reason why there's a different function, it has a different name. Now, what I'm going to ask you to try is, for example, a non-integer input. So, for example, if you plug in 0.5, so 1/2. So you plug in 0.5 into the function. Now, think of this carefully. What is the greatest integer that is less than or equal to 0.5? Okay, integer. So 0.5 is not an integer. So what is the biggest integer that is less than or equal to 0.5? Well, it can't be 0.5, so what is less than? Well, the greatest integer would have to be 0. So at 0.5, I would be at 0. So if I try 0.6, I would be at 0. 0.7, 0. 0.8, 0. 0.9, 0. Until I get to 1. When I plug in 1, what is the greatest integer that is less than or equal to 1? 1, and that's when I jump up to this area right here. That's why you have this little circle to signify that it's jumping up. So then I can try 1.1, I get 1, 1.2, I get 1, 1.3, I get 1, 1.5, 1.7, 1.8, 1.9, I get 1, until I get to 2, and then I jump. And then I repeat and I repeat, and that's why this graph for the greatest integer function looks like a step. And by the way, that is another way for another name for this graph. Some people call it the step ladder. Sorry, the step function or the ladder function. Okay, so the greatest integer function is considered to be neither. Its domain is negative infinity to infinity. As you can see, you can input anything, but think this through. You can input anything, but the output can only be integers. So the range in this case is the set of y values such that y is an element of the integers. This double bar z is the symbol for integers. Okay, so that is all the parent functions that I assigned for you to look up. We will be using this in our test. I would ask you to really memorize this. It will make your life a lot easier in this class and in calculus to have a visual representation of what all these graphs look like, as you can do transformations to it and whatnot. We will not be doing that in this class, as it is something that you covered last year, but it is very important for you to know at least what the parent functions look like. Well, at this point, that will be all for this video, so thank you for watching, and I'll see you next time.